Hi, this is Jacob Nash with JNGL, and this is Unit 6, Lesson 3, and we're going to look at some postulates and theorems concerning similarity. Once again, the symbol means similar, in case you forgot. So just like with the congruence, there are some postulates that can prove that triangles can be similar. So let's see. So let's look at this. So we have a triangle here that I've just drawn that is very good. Sorry about that. And then I'll just draw another one right here. Remember, congruent would mean that they're pretty much exactly alike. Similar just means they're basically the same size, but they could be different. They're the same shape, but they could be different sizes. That's basically the difference. So let's say that this angle over here is congruent to this angle. And then this angle right here is congruent to this one. By this, could we prove that these are similar triangles? Well, let's try to figure it out. Well, we know that all angles in a triangle add up to 180 degrees. So 180. In that case, we know that all the three angles add up to 180. We must know that these two angles, if we subtract their measures from 180, we will get the measure of that. Since these are the same, then those have to be same. So these are not congruent triangles because they could be different sizes and have different side lengths, but they are similar in this case. That being said, if two angles are equal, then we know that triangles are similar. Angle postulate. Let's try something else. This will kind of go back to what we did on the last video, lesson 2. Okay, so these two triangles, we have two right here. Let's just name the sides. A, B, C, and then D, E, F. Now, we already learned that if all of the sides are equal, side, that means that triangles are congruent. But there's something about three sides that can mean that it's similar also. So here's what I mean by this. If the ratios of all the side lengths are equal, then we know that the triangles are similar, but they're not congruent in this way. Not necessarily. So this is what I mean. If A, B over DE. Here, I'll just write it since it's taking so long, and then I'll unpause the video when I'm done. Okay, so we're back. If AB over DE is equal to BC over EF is equal to AC over DF, that means that the triangles are similar. There. And what you notice about this, you might think, oh, that's just some random letters put together. Well, what do those side lengths have in common? AB over, so this is AB over DE. Those are corresponding sides. And you'll notice that it's the same thing for all the other ones also. BC and EF and AC and DF. What does that mean? That means we can say side postulate. But this is only for similarity. You got to remember that. It's not the same thing as the other side postulate that you learned in the last unit. Let's see here. That would be the only other thing that, the only other postulate that we need to know for this video. I'll make another video for other Simularity things. So, thank you for watching this video, and be sure to watch the next one.